We're going to talk about taxonomy. All right. We said so. You had something on the cladogram thing we did that said taxa. This is where that's coming from, that word. All right. So taxonomy. This is how we classify organisms, how we group them together, how we know how similar they are. Okay. Talked about back in the last unit about Linnaeus and coming up with this classification system. Well, that's it. You've probably had most of these in the past. Probably know some little acronym that helps you remember the order. You have to know them in order, right? We're adding this last one up here, the domains. In middle school, you probably went through these. King, Philip, blah, 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 whatever the acronym you used to remember it. Now we're going to add domain to the top. Okay. Someone who does this stuff, the original one was Linnaeus, who's called a taxonomist, not a taxidermist. Had that said last year. I know a taxidermist. No, you don't. All right. Why do we need taxonomy? Okay. It's a common language. Everybody knows what this is, right? That is a skunk. But in every language around the world, is that a skunk? No. So if you're talking to someone from another country, as a scientist, you say skunk, are they going to know what you mean? No. So we have to have a common language for science. For life science, we have a common language. That's taxonomy. Every organism has a specific scientific name that is known the exact same worldwide. Okay? Any of y'all know any of these other languages?
French, Japanese.
It's different. Okay. I know the English one. I know this guy right here. That's all I know. Okay. All right. So, benefits. As we said, the common names of organisms vary. Okay? Think of a raccoon. Y'all know what a raccoon is, right? It's not called a raccoon worldwide. Some people call it a ring-tailed cat. It's one name for a raccoon. Okay? There are different names for them. We've come up with a way so everybody around the world knows what each other's talking about. Okay? That's what taxonomy is. Trash panda, that's another name for it. There he is, the raccoon. All right. You go to Japan, China, and over in the east, they call it a trash panda. What does it do? It digs through the trash. It kind of resembles panda bears. They call it a trash panda. You say raccoon to them, they have no clue what you're talking about. Okay? Prevents misnomers. That's our second benefit of taxonomy. You say starfish. Is it really a fish? Is a jellyfish a fish? No, those are just our common names for them. Because they live in the ocean, we call them some kind of fish. But they're not a fish. Okay? Their scientific name says exactly what they are. Most of all of our scientific names are in Latin. Latin is a universal language for science. Right. Most of our things we do for science are written in Latin. Latin is a base language for most of the other languages around the world. Words in English come from Latin. They come from Latin words. Okay? Even Spanish. A lot of our Spanish words come from Latin origins because that was a base language that everybody knew a long, long time ago. Okay? Here's the scientific name for a raccoon. Doesn't look anything like raccoon. But around the world, you say you go in the science community, they know what that word means. And there's a reason why the raccoon has this name, which we'll get into in a minute. What?
So what is that like? If it's Latin, what does that mean? It's Latin.
Like I said, we'll get into what that means in a second.
It means raccoon.
Last benefit, help scientists find that evolutionary relationship. Is this guy similar to some other organism? Does he share common characteristics with other organisms? Yes, it shows us that evolution and how closely related things are. Okay. All right, that's scientific name. Here's the scientific name for a skunk. Methodist. Sorry if you're a Methodist, because it sounds a lot like that, but that's your religion. Has nothing to do with that. Okay. But everybody knows around the world, Methodist is a skunk. Okay. So, where this came from, we're going to go back before Linnaeus. Okay. Over 2,000 years ago now, Aristotle was the first person to put organisms into categories and give them a different name other than what everyone was calling them. Okay? He divided into plant and animal. Does every organism fit in plant and animal? No, it doesn't. But you think about 2,000 years ago. Did they have the stuff we have now to see all the organisms? No. Could he see bacteria? No, they didn't know what bacteria was. All right. So all they could use is what they could see. And what they could see were plants and animals. So he grouped them as plants and animals. And then he went one step further with it and said, some live on land, some live in the oceans and seas or lakes, some live in the air. Okay? So this was the first breaking of organisms into groups. Right. Then you had what? Do we have some that do both, or two of these, or all three of these? Yes. And so that was the problem here, was that it didn't exactly work right. And so there has to be some changes. John Ray was the first to use Latin for naming, and he did it with plants. Botanist is a person who studies plants. All right. He took all the plant species that were known at the time and gave them scientific names using Latin. Okay. Now, you saw a scientific name. It was 2 words. Okay. All scientific names are 2 words. You're going to see that in a second. His name for each organism was a sentence-long description of the organism. So instead of writing skunk, you had to write this long sentence. Long fur, black, white, 4-leg, 2-eye. I mean, he had this long, basically a full description in Latin of that organism. Now, is that something everybody wants to talk about whenever if I'm going to go overseas and talk to someone about a skunk, do I want to have to say a whole sentence every time I say skunk? No, so it's a start to what we have. Everything gets modified as it goes through. All right? And then we get to Linnaeus. Linnaeus, we talked about him already. He came up with that classification system, kingdom, phylum, class, order, genus, family, genus, species. But he also came up with binomial nomenclature. Okay? What's the prefix bi mean? 2. What do you think nomial means? Huh? What are we talking about doing here? He is doing what for each organism? Giving them a... Nomial means name. So, to name, there's nomen again. To name naming. That's what binomial nomenclature means. To name naming. Okay. 2 words, scientific name for each organism. All of you have a 2-word scientific name. And it's all the same. You are Homo sapien sapien. That's what humans are. Doesn't matter what color, what race, what ethnicity. All humans are Homo sapien sapien. All right? Because all that is different characteristics, different traits. But we're all still the same species. Okay. So here's how we do it. Some rules about naming. All scientific names have to be, if you're typing them, like on the computer, has to be in italics. If you're writing them, they have to be underlined. All right? Both words have to be underlined or in italics. That's the first thing. Means there is some meaning to this word that you see. The second thing, the first name is the genus name. Up here on the chart on the wall, the genus is the second level. So we put its genus name. And it's always capitalized. Okay? First name's always capitalized. You write your name on paper, on some document, do you capitalize your name? Yeah, all right. You're going to capitalize the first name. The second name is the species. That's the finite piece. And it's always lowercase. Okay? It's not the last name. It's a subgroup of the first name. Not in this.
What's the subject for? What if your name's like Mary Beth?
That's a middle name.
No, but like.
It's not the subgroup. It's still one person.
Isn't like your last name a subgroup though?
It's
Like
still
your family?
one person.
But like your subgroup of your family.
But you're talking about one person. Is there any other Levi? How you say your last name?
Polion.
Is there any other Levi Polion on this planet?
Yeah.
No, there's not. You're talking about one specific organism. That's why it's different. We're talking about a full genus and then a species within that genus. It's more than one organism. It's many organisms. There's no one going to have the same genus and species name. No organism. Every species has its own name. That's why you don't have to capitalize the second one, because there is no other one. You capitalize both names for a person because it's only one. You're the only one. Okay.
I'm not the only one. What about when you look up on Instagram? But that's they all the same organism.
It's not the exact same organism. There you go.
Oh,
Now you're thinking.
I thought you were talking about the same thing.
Oh, that's one organism. The fourth thing. Most of the time it's a Latin word. All right. And that Latin word describes some physical characteristic about that organism. Okay? It has something to do with that organism. Kind of describes it, but not in that full long sentence like John Ray did. Okay? So here's an example. It's a black squirrel. Here's this name. All right? Sirius carolinus. Carolensis. Can't talk this morning.
Are they still around?
Mm-hmm. Now, anybody know what this first word means in Latin? Just take a wild guess.
Black.
Means black. You ever watch Harry Potter?
Yeah, Sirius Black.
Sirius Black. Where do you think its first name comes from? It means black. Okay?
So his name is Black.
This name. What do you think this name comes from? Look at the name. Where do you think this squirrel is found? In the Carolinas. A black squirrel found in the Carolina region of the United States. Every name has some meaning that attaches to that organism. Okay? Chimpanzee. Pond troglodyte. That is the scientific name for a chimp. Pond troglodyte. What? All right. Taxon. This goes with the taxa we talked about with the cladogram. All right. Taxa is plural for taxon. Taxon means one level. Taxa means multiple. Okay. So we have 8 levels. They are the ones we already discussed a little bit. You should know these. There is an order that you have to know them in. Broadest to most specific. All right? If you look at specific, what word on this chart looks like that word? Kingdom, phylum, class, family, order, genus, species. Which word looks like that? Species. Which one you think is the more specific, the smallest group? Species. The broadest would be domain. Okay? So domain, kingdom, phylum, class, order, family, genus, species. Notice how they're written. Notice how they're written on the screen. What difference do you see in here? Genus and species are both italicized, and species is the only one that is lowercase. Okay? You have to know these in order. I will warn you now, there will be questions about that. You have to know them in order. It's for a reason. There are fewer kingdoms than species. So as you go down the list, your number of them get bigger and bigger and bigger. Okay? There's only a few kingdoms, but there's 1,000,000 species. You get a lot more as you go down, so you got to know them in order. There's going to be questions you see either on a test or on STAR that's going to ask you things about which one has more groups of organisms or something to that nature. You have to know them in order. There are the fewest domain, greatest number of species. As you go down the list, the number increases. Okay? Because we get more and more specific. We could have a family of monkey-type organisms, but are they all the exact same? No, I bet you could name me more than one. Chimp, orangutan, what else? Monkey itself.
Lemur.
Gorilla.
It's not a monkey. Gorilla.
Wait, it's not.
A silverback gorilla. There's two right there. But you see, all those are species of the same family. All right, so we got more than one. All right, so here are they all in order. There is an acronym for you to use if you don't already have one that you've used in the past. There's one for you to use. Okay? We saw this back with evolution and how things were grouped and things were similar. All right? We've got our, this is wrong. This should be a polar bear, not a grizzly bear. This is the polar bear. He's in the same kingdom as all of these guys. Who else fits in that kingdom? Kingdom Animalia. Who fits in there? Yeah, deer fits there. What else?
Panda. Black bear.
Us. We're in the same kingdom as a polar bear. We're in the same phylum as a polar bear. Chordata. Chordata means you have a backbone. We're in the same class as a polar bear. We're all mammals. Do we eat meat? Eat other animals? Yes, we do. So we're in the same order. And that's where it breaks off. Because these are all bears. The family becomes just the bears. But we are similar to every one of these organisms from here up. You're in the same family with a starfish. You're in the same phylum with that squirrel right there. You're in the same class as that fox because of similarities in our makeup. Okay? If two organisms belong to the same class, what other taxa do they also belong to? If two organisms belong to this class, so we'll take the black bear and the red fox. What other do they belong to together? For sure. Phylum. Kingdom.
All the way to genus.
And the same domain. They belong to everything above together. All right, second question. Which organisms are more closely related? A grizzly, which should be polar bear, and a panda or a polar bear and a black bear?
Polar bear and a black bear.
Why?
Because they both have the same genus.
As you go down, you get closer and closer related. All right? A polar bear and a black bear are very closely related. All right? Are they the same? No, because they have their own species. They're their own organism, but they are very closely related. Okay? All right, domains. This is the biggest, broadest taxon. It includes a lot of different organisms, and there are 3 of these. This is the new part that you haven't had yet. You know about the kingdoms, hopefully. You remember that from middle school. We're adding domains. There are 3 domains. Archaea, bacteria, all of these are prokaryotes, and then we have eukarya. What's that mean from yesterday? Eukaryotes. What's the difference in these 2 from yesterday? One has membrane-bound organelles and a nucleus. The others don't. Now, why do domains? They haven't been around very long. Why were they not there when Aristotle did all this? Because could he see all this stuff? No, didn't know they existed. So we've added them throughout the years because we know now that they exist. And are they the same as us? Is the bacteria the same as us? No. Is it the same as a plant? No. So they have to have their own category, their own domain. And we'll get into all those domains tomorrow. All right. We're going to use the chart tomorrow. I have the chart. I'll get it to you tomorrow. But we're going to look at some terms that we have to know for this unit. All right. Unicellular. What's uni mean? One. Made of one cell. Give me an example of something made of one cell. A living organism. What? Bacteria. Bacteria are single-celled organisms. They are unicellular. What's the prefix multi mean?
More than one.
Yeah, many. All right. Give me an example of a multicellular organism.
Dog.
Any of those work. Prokaryote and eukaryote we talked about yesterday. You saw that in the video. No nucleus, no membrane-bound organelles. Eukaryotes have them. You do. Autotroph. Give me an example of an autotroph. Plants. They make their own food. Okay. Heterotroph.
A dog.
Yeah, pretty much everything other than, well, plants and some protists.
Actually,
Okay.
do
Huh?
a fly trap.
No. You'll see. We'll debunk that theory here shortly. They're still autotrophic. They don't eat. It's a reflex. When something lands on them, they close. It has nothing to do with eating. They don't actually eat. No, they
Wait, are those good?
whatever lands on them, the thing closes up on them, and then they secrete a whole bunch of chemicals that basically dissolves them alive.
Are those good to have in house? You don't know.
Don't know. You put your finger in there, they'll close on your finger. Yes, but you can pull your finger out.
Are they be like,
A fly can't push it open and get out.
will your finger like get acid burn or whatever?
Well, not if you pull your finger out.
Well, if
You leave it in there long enough, the chemicals will start to dissolve. It's what they're made for.
Wait, will you feel it on your finger?
I don't know. Never done it.
Will it dissolve your finger?
Never done it. Don't know. I still got all 10 of mine.
I'm gonna look it up.
All right, the last 2 words. Modal and non-modal. Modal looks an awful lot like mobile. If you are mobile, you do what? You move. All right. Give me some example of something that's modal that we haven't said yet.
Wheel.
That's not an organism. Bear works. It can move. All right. What's a non-modal?
A plant.
Yeah. The day plants become modal is the day I go find somewhere and hide. If a plant gets up out of the ground and starts walking on its roots, I'm gone. Because the world is coming to an end. All right. So here's our 6 kingdoms. Go ahead and get those written down. Get those 6 kingdoms written down. You have archaebacteria, eubacteria, protista, fungi, plantae, animalia. All right. Now, thinking about our 3 domains. Which domain do you think these are going to be in? You got the domains written right there before this. What domain do you think archaebacteria are going to fit in?
Bacteria.
Nope. Look at the first part of the word. They're going to fit in archae. Eubacteria are probably going to fit in? Nope. Bacteria. And then all these other ones fit in eukarya. They're all eukaryotes. What?